So on this problem, where are we starting? What is our unit that we're starting with here? Okay, grams of C12H22O11, correct? And what are we going to? Which is a type of particle, correct? So maybe off to the side to start us off with these questions, we might want to remember our conversion chart from the other day. You've got mass, moles, and particles. Y'all remember talking about this, right? What was the conversion factor that gets us from mass to moles? Do you remember? 1 mole equals the molar mass. And to go from moles to particles, where a particle could be a molecule, the conversion factor is that 1 mole is equal to 6.02 times 10 power of 23. That's the number of particles in 1 mole of a substance. Right? Those are our conversion factors. Now on this problem, where are we starting? Are we starting with grams or particles or moles? Because it says we have 10.8 grams. So we're starting from this location up top. And what are we supposed to go to? Particles. So we're supposed to go down to here. How many steps do you see? I see 1 conversion and 2 conversions, so here's what we should draw out to start us. With 2 conversions, we're going to need 2 lines, just like that. 2 conversions, 2 lines. You'll see that this is different than what we were doing last week because now these are going to have multiple steps in them. Our first step that we're going to do is to convert from mass to moles using the molar mass, and the second step is going to be to convert from moles to particles using the 6.02 conversion. So I'm going to need to find the molar mass. So why don't we take a quick second and let's find the molar mass of C12H22O11 off to the side. You know what the molar mass is, right? When we add up the masses. So that would be 12 times 12.011 plus 22 times 1.008. That's the mass of hydrogen. And the mass of oxygen is 15.999 times 11. So I'll let you add all those up real quick. 12 times 12.011 plus 22 times 1.008 plus 11 times 15.999. We'll see everyone putting that in their calculator. In doing that, I got about 342.297. Is that what y'all got? 342.297. That's the number of grams that's in 1 mole of the substance. I just found the molar mass. Good? So what number has to go on top right here? Yeah, we always put that number that they started us with in that top left box, correct? We've always done that. So I should put 10.8 grams of C12H22O11. And what unit needs to go in this bottom left box or bottom right box right here? We know for sure grams of C12H22O11. And I'm supposed to convert from mass to moles using this first step. So I know that that's going to be the molar mass that goes right here, right? Which is 342.297. That's the number of grams that's in 1 mole of the C12H22O11. I've used 1 conversion factor. I've moved 1 step. I've converted to moles now. Am I done with my problem though? No. I need to convert to particles, correct? If moles is on top, what needs to be on bottom right here? 1 mole of C12H22O11. And what's going to be on top of that? Right, that's the number of molecules that is in that compound. So let's pay close attention to this real quick. I want us to make sure we're outlining this before we do our final math and all that stuff. We were converting from mass to particles because the problem said that, right? How many steps do you see here? I need to do 2, right? Conversion 1 and conversion 2. 1 and 2. So I needed my 2 lines here to show that I was going to have step 1 and step 2. My choice of which direction to put stuff is based on canceling out my units, leaving me with the units that I want in the top right-hand box. So let's multiply this out. 10.8 times 6.02 E23. Don't forget about your E. So again, that was 10.8 times 6.02 E23. There's that step that I've done thus far. I'm not going to hit the multiply by 1 button because it doesn't really make a difference. Right? And then I'm going to divide this by 342.297. And I could multiply that by 1, but it doesn't change the bottom at all. Hit my enter button. How many sig figs did I have in my original number? So I can take the 1, the 8, and that first 9. The second 9 would bump it up. So I've really got to write down 1.90 times 10 to the 22nd molecules. Good? There's a 2-step problem. Let's look at problem number 2. Let's work that one out together as well. I'll let you read it real quick and let's go over where we're starting at and where we're stopping at. What are we starting with? It says, what is the mass of 0.95 moles of KOH? So what are we starting with? Moles of KOH. And where are we going? We're going to grams or mass. It says, what is the mass? So that's where we're going. So if I write out my little conversion chart off to the left-hand side, remember we've got moles in the middle, we've got the mass up top, or we've got the particles down at the bottom. You'll notice that you'll be writing out this conversion chart a whole lot. Where am I starting at here? Am I starting at particles, moles, or mass? I'm starting with moles because it says I've got 0.95 moles, so I need to draw maybe my little asterisk right here at moles. And what am I going up to? So am I going up or am I going down? I'm going up to mass. How many steps is my problem going to be? Only that one, right? Only that one conversion, so we're going to draw that one line because we got one step. What is the conversion we're going to use to go from mass to moles? 1 mole is equal to what? Very good. 1 mole is equal to the molar mass. Do we remember how to get the molar mass of a substance? So let's take about 5 seconds, maybe 10 seconds, and find the mass of KOH, the molar mass of it. The molar mass of KOH. Periodic table in hand. You can find the molar mass of it. K is 39.098, O is 15.999, and H is 1.008. So did we get 56.105? So what have we just found here? The molar mass. 1 mole is always equal to the molar mass. So now that we know our conversion factor over here, 1 mole is equal to the molar mass of 56.105. What number is going to go in my top left box? 0.95. And that's moles, right, of KOH. What unit has to go on bottom right here? 1 mole of KOH. And what is 1 mole of KOH equal to? 56.105. Very good. Grams of KOH. So we're going to multiply our 0.95 by this molar mass. We could divide it by 1. Wouldn't make much of a difference. We can. We choose to use 2 sig figs at the end because we had 2 in the beginning number. Let me know what we got. So just 53, right, for sig figs? Grams of KOH. Cool? Good? Okay, good. So we should write out mass, moles, particles, right? And we know we have our conversion between each one of those. And we are starting at, you said mass? Okay. And where are we going to? We're going to moles or particles? Particles, because a formula unit is a type of particle. So we're going to go down to particles, which is including formula units. How many steps do you see here? So I should draw out my line. And how many vertical lines should I be drawing here? Yeah, 2, because I've got 2 steps. Now the other thing we could be doing is going over our conversions. What is the conversion between mass and moles? 1 mole is equal to what? 1 mole is equal to the molar mass. So I know I'm going to use that first because that would be the first step going downward. And the second step would use the 6.02 times 10 to the 23 conversion. It's equal to 1 mole. So maybe off to the side we might want to find real quickly the molar mass of the potassium permanganate, KMnO4. So we're finding the molar mass, which is 1 mole being equal to so many grams of KMnO4. And what did we get for that molar mass? So 158.032. Perfect. So what number needs to be put in our top left box here? Correct, 55.67 grams of KMnO4. Always the number they prompt us with is going to go in that top left box. Now on my first conversion, I'm going to go from mass to moles using my molar mass. So what unit needs to be going on bottom here? Grams of KMnO4, right? And I know that there is 158.032 grams in 1 mole of KMnO4. Now if I stopped my conversion right now, if I just stopped, what unit would I be at? Moles of KMnO4, because my grams would cross. But I don't want moles, do I? I want the number of particles, the number of units. So I should do my next step, which would include putting 1 mole of KMnO4 on bottom and 6.02 times 10 to the 23rd particles, or in this case, units of KMnO4 on top. I'll let you with your calculator put this in real quick and then we'll check over the number and we'll make sure that we've got that correctly. Let you look at this. So now that we've checked the answer for number 3, let's look at number 4. I'll let you read it real quick and design over on the left hand side where your chart and where you're starting and where you're stopping. Hopefully this is what you have. We're starting with the number of particles, correct? And working our way up to the mass. How many steps is this problem going to be? It's going to be 2. Having a total of 2 steps, that means we're going to draw our 2 lines there. And what number is going to go in this top left box? Yeah, sure. take it. You said what? 5.23 times 10 to the 21 units of that gold 2 sulfate, or gold 3 sulfate, I apologize. Au2SO43. And what's got to go on the bottom right here? It's going to be 6.02 because we need to work our way back up to moles in our first step. So 6.02 times 10 to the 23rd units is in 1 mole of the Au2SO43. And how about in this last step? What's going to be on bottom right here? 1 mole of our substance, and what's on top? So maybe we also need to take some time and find the grams of that gold sulfate that's in 1 mole. So let's pause and let's find our molar mass because we need it for that blank right there. That makes sense. In our second step, we would need molar mass opposite of 1 mole. So let's find it. Question, sir? Uh-huh. Hmm? That from your periodic table?
Yeah.
Yep. $682.12?
Yes.
So a huge molar mass. That would make sense. It looks like a huge compound. So to solve this, what am I going to multiply together first off? Okay, so 5.23E21. Make sure we're putting in the E, right? Remember the E we got with a second and the comma button. Second comma, which was the E button. Right there. Comma button. And then we're going to multiply that by 682.12. Correct? And then divide that by 6.02 E23. Let's make sure we got this correct. Did y'all get about 5.92? Give or take. So with 3 sig figs, 5.93, and this should be grams of the gold sulfate. Good? So again, we're checking the work on question 5. We were starting out with grams, were we not? And we were going to molecules. So you'll notice that I started my chart off with mass with the asterisk by it, running down to particles. That gave me 2 steps, so that was 2 lines. The given number always goes in the top left box, and I just used my 2 ratios, canceling out my units along the way. Yes, sir, question? That's the molar mass, right? And you see, if you remember, this right here, and hopefully everyone's paying close attention, this right here is the first step, and this is the second step, right? Agreed? The first conversion, the second conversion. In our first conversion, we were supposed to use the molar mass, starting at the mass and working our way down. And in our second conversion, we were supposed to use the 6.02 E23. So it would make sense that the numbers go just like this. The reason that they're not flipped, the reason they're not reversed, is because grams was on top, so grams has got to be on bottom. Just like that's the reason why the 6.02 times 10 to the 23 and the 1 mole's not flipped. Moles was on top, so moles has to be on bottom. If you think about it, your molar mass is always opposite of 1 mole, and your 6.02 E23 is always opposite of 1 mole. Good?
Is it a molecule instead of unit?
Well, honestly, it should have been written in units. The problem should have. Should have said how many units, because it's an ionic compound.
Oh.
Molecules usually for covalent. So that was my fault when I was writing the worksheet. Good? Okay. Let's skip number 6 for now, and we'll come back to that in just a second. Why don't we jump down to question 9 real quick, and let's work that one out as well. Our effort is always to start with the first number they gave us. The number they gave us goes in that top left box. Correct? Now, what unit has to go on the bottom right here?
1 mole.
Moles of Na2O. And I know that since I'm going to mass, the only conversion I'm going to use is the 1 mole is equal to the molar mass conversion. So that means that since I'm using mole down here, I've got to have only 1 mole. And the molar mass is supposed to go on top. We found the molar mass equal to 1 mole, 61.979 grams of Na2O, sodium oxide. 61.979 times 0.578. The answer I got was 35.8 grams of Na2O. Is that what y'all got? 3 sig figs? Okay.